Hello everybody, hope you guys are doing well, and in today's video we will be going over the latest updates for Obelisk. This is the fourth update video, and we have quite a bit of new things that we've added, including the deployment layer, which we are finally stabilizing. We've added a separate inference server. We've redesigned our code completely since the last time we spoke, and we're excited to share all the updates and details with you. So without further ado, guys, let's get right to it. We've done a lot of redesign since the previous version. Previously, we had the memory nodes and a couple of other details, but what happened was we completely changed the language. We moved it from Python to TypeScript. So what happened was we isolated our inference layer into a single inference service, and that's the only service that runs in Python. Now we're going to delete all of these extra folders and files once we finalize this move, but we just recently converted everything to TypeScript because it makes a lot of sense for ease of development, and because our inference layer is running Python, we don't need the API layer to be in Python. It's a lot easier to have it be set up in TypeScript. It's a lot cleaner. Also with the Docker setup, makes it a lot more lean, the actual images. So when it comes to the source, so it's again the same thing, just in TypeScript. We have the core folder, which has the execution engine, and it has the runner. And in the execution engine, we have the autonomous runner, and we have all the nodes. And here you can check out the different nodes that we have. The same thing as in Python, but this is all converted to TypeScript. It still needs a little bit of fine tuning here and there, but everything does work, and we're happy to move forward with this conversion. It was necessary. So we're excited that now our code base essentially has both TypeScript and Python. JavaScript comes from the light charts library, but TypeScript is our back end, so it makes it super easy for you guys to work with the TypeScript back end. And also the UI is also in TypeScript. This is a React Next.js app, and this is essentially this deployment right here, the build website, which you can deploy yourself, and all it does is connect to a different backend for the deployments, which we will go over here in just a minute. So that's a little bit about the code, mostly just moved to TypeScript, and we isolated the inference to have its own inference layer. How does it affect the actual workflows? So as you can see here, we no longer have a load model node. Instead, we have an inference config node. So this is the current default workflow, and this will probably change. But when you go to the website build.theobelisk.ai, this is the workflow that would load. You can zoom in, zoom out as you like. So we'll go over it a little bit. We're not going to recreate everything because this takes a long time. We'll just go over how everything is wired up so you guys can take a look. And this might change a little bit in the coming days, but this gives you a basic template of a Telegram bot that reads messages and decides whether to reply. So it all starts with this Telegram listener. It's technically an autonomous node. It has a couple of outputs, has a trigger, which we're not currently using, but it could go into the trigger of a text input prompt if you have a specific prompt you want it to trigger. We also have here the value for the actual bot token. So this is something you will need to put in when you're about to deploy it. So when you want to deploy this agent, the only thing you have to do is click deploy, put this key in here, put a value, which is going to be the bot token you get from bot father. You have to send a message to bot father on Telegram. He'll give you a bot token. You put here, click deploy, and you're all done. So for now, you have this Telegram listener. It takes the bot token. It has the poll interval in seconds. How often does it poll? The actual server tick for our runner, I think it's set at 100 milliseconds. So 2 seconds is fine. So every 2 seconds is going to poll for the latest messages and updates for the bot. As you can see here, same kind of model. We have the memory creator. It takes each message. This time it's a little bit different compared to our previous memory creator. In the previous one, if you go here, you see here we have a query and we have a response. So it takes in two things. But in this case, we only have a message. We don't necessarily have a response because it's not storing interactions. It's just storing messages. The memory creator is going to store a message. Every 20 messages is going to summarize the conversation by using this model, and it was going to save it to the storage. Nice and simple for the memory part here. The memory selector, again, takes in a storage instance, takes in the chat ID. Now, the thing with the memory selector, it selects it based on the chat ID. Based on the chat, it's going to select the relevant memory because it's going to get a lot of different memories in different chats. But this one, it wants to select the best in the chat ID, which the Telegram listener node outputs a chat ID here, which is we use. The model comes from the inference config, which is going to essentially route to your inference endpoint. And you can set up locally on your server, if on your computer, if you want to run this locally on your desktop. And then the memory selector, other than that, it takes the chat ID and the actual message that it needs and the model. So that's all the four things it needs. For the output, it's going to output a context, which means it's going to output the recent 20 messages regardless. It's going to feed it into our inference node. And it's also going to output the original message that it got as a throughput to make it easier for just the workflow to be connected to. So as you can see here, we have a query that gets passed through here. So the way it kind of works here, so this is the memory selector. It outputs a context and a message. But now the cool part is we have this binary intent node. Let me go over this new node, which is going to be a really useful node for anyone building AI agents. A way we abstract a certain action. We abstracted a Boolean, essentially like an AND, an or an XOR. It takes in a message, any arbitrary message, and it takes in a model because it needs to run inference. And what it does, it gives this model the system prompt. It says, is this message directly addressing or calling the bot? So in this case, the binary intent is trying to figure out, is this message calling the bot or not? It outputs a yes or a no. And if it's a yes, then it's going to fire off this message. We might redesign how it actually outputs it, but the idea remains the same. Give it a nice prompt. It's going to run this message through, and it's also going to output a JSON version of a true and false. You're getting run through the parser, and then it is going to output a message if it detects that the model output true. It's a nice binary intent node that will be useful across many use cases, including what if you want to take in some data, you want to analyze it according to some criteria, and you want to you want to make a decision whether to act on it. That's the best way to describe this node. There's just one big piece in a huge part of our puzzle. And as it goes forward here, you see, so this is what triggers this inference. Only if this binary intent decides that this message is worth responding to, then it will actually trigger the actual inference where it will process the message with some context that it gets from the memory selector using this model, and it gets a system prompt. And finally, it will output the result and send the message back to Telegram. And here you see the chat ID is kind of hooked up because we need the initial chat ID. We want to respond to this chat ID. We can also output a message ID and hook it up here so that when you send the message, it replies to this message ID if it exists. So that is one loop. For example, here we have the default Telegram loop. We're still working on it a little bit. You guys seen it in action in our groups. The next kind of part to this, the best part about designing this is now you can hook up a separate layer, an autonomous layer where it just decides whether to send a message or not. It would be powered by a scheduler loop, so it would be a separate kind of workflow in a way, but it can hook up into different parts of this other workflow if it needs to. Something like this is a way we would route a separate loop that would still be part of the same system. So it would still be part of the same agent, but now we have two separate loops. And then as you zoom out, you can have this be the main loop. You can have an autonomous loop. Then you can have a separate maybe analysis loop that analyzes. You can have a short-term memory loop. You can have a long-term memory loop. So it's an easy way to expand this and to really have some complex workflows. So I hope I showed you guys a little bit about this. I'm not going to spend too much time on it, but you guys can play around with this and you can currently deploy this and run these agents if you want to try it out. So other than this, the next thing we are working on is making sure that our agent deployments are working well, and especially the inference. Right now, the inference is a little bit slow. We can optimize it a tiny bit because inference is quite expensive. We did rent a GPU server but it is quite expensive to run inference. So for the next couple of updates, we're going to be fine-tuning our Telegram nodes and making sure that the Telegram bot and our binary intent system prompts are a little bit better. It's a little more human, and we're going to start adding complexity in terms of adding more nodes and cycles and different loops. So thank you guys all for watching and checking out this video. Make sure to check out our NFTs. They are all minted, but we do have some NFTs on sale. They are going to be reflection NFTs, so we highly recommend you guys check them out and make sure that you grab one because they are listed for relatively cheap. I think you can grab one for 0.001 ETH right now. So we highly recommend grabbing them because when the energy token launches, the NFTs will start earning reflection. The owner of the NFTs will start earning reflections. Thank you a lot for checking out this video, and I'll see you guys in the next one. Peace.